Hello and welcome to Intermediate Algebra, Unit 7, Lesson 4. We will be solving rational equations. So that is our lesson objective. We're going to solve equations that contain rational expressions. We've looked at simplifying rational expressions, multiplying, dividing, adding, and subtracting. And now those were all expressions that did not have an equal sign. Now we're going to look at solving equations, and we're going to see that it's actually easier in some ways than some of those other things we did, because the first thing we can do, because we have the equal sign, is do something called clear the fraction, when we multiply everything on both sides by the common denominator, and all of the denominators will reduce away. So, reminder, here is what we mean by rational equation. It contains one or more rational expressions. Remember, those are terms that look like fractions. They might have variables in the denominator, they might have numbers in the denominator. So in this case, 4 over x is a rational term, and then 5 over 2x. 3 is rational also. Every integer is considered rational because it can be written as 3 over 1 to put it in fraction form. So these are both examples of rational equations. You don't have to have an integer in it. You could have everything as a fraction. But to solve it, we find the least common multiple of all the denominators, or whatever we would use as a least common denominator if we were trying to put every term in both sides of the equation over a common denominator. And when we multiply every term by that, every term has a piece that reduces unless the piece wasn't a fraction to begin with. So here we have our first example. We're going to solve the quantity x plus 3. And remember, there are implied parentheses around this x plus 3 because of the fraction bar. You may find it helpful to avoid mistakes to put parentheses around the tops and bottoms of every fraction. I haven't done it here for the sake of ease of viewing, but that might be helpful for you as you write out your steps. We have x plus 3 over 6 minus x minus 2 over 4 equals 3. So if I were to find the common denominator between 6 and 4, in the case of the 3 there's a 1 in the bottom so it doesn't contribute, I would have 12 because 6 goes into 12 twice, 4 goes into 12 3 times. So what I'm going to do here, rather than rewrite this as something twelfths and this is something twelfths and this is something twelfths, is I'm going to take that 12 and I'm going to multiply each term on both sides by the 12. And what will happen is, where I had a fraction, the denominator of the fraction is a factor of 12, so it will reduce, and I will end up with an equation that doesn't have any more denominators except for, of course, 1. So I take 12 times the x plus 3 divided by 6, and 12 over 6 leaves me just a 2. And here's where that parentheses is important. And then I do 12 times the x minus 2 divided by 4. Well, 12 divided by 4 is 3, so the 12 over 4 will reduce to a 3. So you just multiply that numerator by the 3 as I've shown here. Now, often students forget about the other side. If I'm multiplying the left by 12, I have to multiply the right by 12 to maintain the truth of this equality sign. So I'm scaling up both sides by 12, so the 12 times 3 is 36. Now I look at this equation here, and it looks much simpler because there are no fractions. So now I distribute, and I have to be careful distributing the negative 3. I get 2x plus 6, and then negative 3 gives me negative 3x plus 6, and that equals 36. When I combine 2x and negative 3x, I get negative x. 6 plus 6 is 12. If you didn't distribute the negative properly, your numbers would have become 0. So if you had tried this ahead and didn't get the 12, it's probably you made an error distributing the negative. So now I have negative x plus 12 equals 36. I want to get all the numbers on one side, all the letters on the other. So I subtract 12 from both sides and I get negative x equals 24. Students often get confused when you see this. You're almost there, but not quite. So if the opposite of x is 24, if you divide both sides by a negative 1, you'll get x is negative 24. So this is telling you the opposite of x. Your task was to find x, so you have to finish by doing that division by negative 1. Okay, so now here's one, and what this has in common with example 1 is there's just numbers in your denominator. We are going to see examples where we have variables in our denominator. But if there's just numbers, you find the common denominator the way you always have. Now, if you couldn't find the common denominator or the least common denominator, you could just always multiply 4 times 14 times 7. So in a moment, I want you to stop this video, and I want you to try this problem. Don't forget about your parentheses on the tops and even on the bottoms, even though there's only one number there. That's helpful to write those in many times. I want you to stop the video and try this and come back and see the solution. All right, so you're back and you either have an answer or you're a bit frustrated. Hopefully that's the first thing. So I'm pretty good with my numbers, so I recognize that 4, 7, and 14 all go into 28. If you multiplied 4 times 7 times 14, you had a much bigger number here, and you would have still been able to reduce your fractions, and your numbers down here just would have been bigger on both sides. So if you're really not good at finding the least common denominator, you can just multiply all the denominators together. You just have to reduce in the end. So I saw 28. That indeed is the least common denominator. And again, there's parentheses around this numerator x minus 3. So what you're doing when you multiply each term, and notice rather than put this side in parentheses, I multiplied each term, showed you how each term gets multiplied by 28. What you're really looking to do is reduce that 28 with the denominator of each term. So you're really looking to see, does 28 over 4 reduce? Because there's an understood 1 under the 28, and if you were to multiply these, you would do 28 times the top, 1 times 4. Well, you could just as easily do 4 times 1 and put the 1 under the x minus 3. That's what the commutative property of multiplication allows me to write this way. You don't have to write that step, although I encourage you to write as many steps as you possibly can find to avoid mistakes. But that's what I'm doing when I come up with this 7, is 28 divided by 4 is 7. So you're always taking whatever you multiply and looking, whatever you chose for a common denominator, and looking to reduce it with the denominator of each individual fraction. So in this case, I get a 7 times my x minus 3. On the right side, 28 over 14 becomes a 2. And that leaves me with the numerator of the original, so that's times 5. And here 28 over 7 becomes a 4. That's times x plus 5. Now this is my new problem to work with. It looks much easier because there's no fractions. I distribute the 7. 2 times 5 is 10. I distribute the negative 4, and I get a negative 4x minus 20. 7x minus 21 equals negative 4x minus 10. 11x is 11, and x is 1. So that's how you solve that one. Hopefully if you made a mistake, you found it. And let's move on to another one with variables in the denominator. So in this one, some of our denominators have variables in it. 1 over x equals 1 over 5 plus 3 over 2x. The denominator, the lowest common denominator, would be 10x. If you just multiplied them together, you would see 10x squared. That would introduce some more reducing in the end and making sure you don't have an extraneous solution if you use that. But I'm going to use 10x because that's better form, and I recognize that 10x would be the least common denominator. We also note that x cannot be 0, so if in the end x equals 0 is an answer I get, I have to recognize that that can't be true. So I don't list that as a solution. And that's because we're not allowed to divide by 0, and replacing the x's with 0 would create a division by 0 in not only one place, but two places. Only has to happen in one place for it to become a restriction, though. So 1 over x equals 1 over 5 plus 3 over 2x. I multiply each term by 10x, and on the right I've put the terms in parentheses, so I'll distribute that 10x. So I get 10x, and I'm looking to reduce it with the x on the left, and that becomes a 10. So in the first term on the right, 10x over 5, the 10 and the 5 reduce to a 2, so I'm left with 2x times 1, so that's just 2x. 10x over 2x is 5, so I'm left with 5 times 3, that's 15. Now I subtract 15 from both sides, and I get negative 5 equals 2x. Divide both sides by 2, negative 5 halves is x. And if I replaced x with negative 5 halves, I would indeed have negative 2/5 on this side, and I would end up with negative 2/5 on this side. The equation would be true. So the process is the same whether you have variables or numbers in your denominator. You find a least common denominator, multiply every term, and reduce your fractions to do what we call clearing the fractions. So here is one for you to try. It's very similar. I want you to, in a moment, I'm going to ask you to stop the video. I want you to write down what x cannot be just based on looking at this problem. What would cause a division by 0 if you replaced x with that number? And I want you to try this, stop the video, and come back in a moment. Okay, you've started the video again, so I assume you're back. Here's the answer with some steps written out. So the restriction you should have noted was that x cannot be 0. You can simply write that x with an equal sign with a line through it, 0x not equal to 0. So my common denominator, I have a 2x, a 3x, so the x has to be there certainly, but I don't have a 3x squared or an x squared anywhere, so I only need x to the first. 18, 2 and 3 both go into 18, so it looks like my least common denominator will be 18x. Now you could have gotten 5x times 18, which would have given you 90x. If you did that, you would have gotten bigger numbers and maybe had to reduce at the end. So 18x over 2x reduces to a 9. The x's reduce. 18 over 2 is 9. I multiply that by 5. 18x over the 18 reduces to the x. I multiply that by 17. 18x reduced with the 3x on the bottom leaves me with a 6. 6 times 1 gives me the 6. I multiply the 9 times 5. I add 6 to both sides, and I divide by 17 to get x is 3. If I put in 3, I will, and I do evaluate, both sides will come out with the same number. They'll come out with 5/6. Sorry. So this example differs in a couple of ways. One, we do have variables in the denominator, but we actually have a variable expression, and it's very important that you remember that there's parentheses around this denominator and this denominator. And under this 9, there's a 1. Okay, so we have an integer in this one, plus our variables aren't just the variable by themselves, it's a variable expression. You treat that as one quantity because this fraction bar behaves like a grouping symbol. And the restriction on x is, well, what would x have to be to create a 0 in any of the denominators? Well, if x is 3, each of these denominators becomes 0. So x can't be 3 because I can't divide by 0. And a fraction is just a way of writing division. So the bottoms can't be 0. That fact will follow you all the way through your mathematics and your engineering studies. You can't divide by 0. When you divide by 0 in a circuit design, you get a lot of smoke. So you really cannot divide by 0. So that's where that restriction comes from. Don't let that right there, if the problem states x not equal to 3, don't let that be the reason you can't solve the problem. Don't let that confuse you. They're just reminding you you can't divide by 0. So I'm going to multiply. The least common denominator is fairly simple in this case, since these two are the same and there's just a 1 under the 9. The least common denominator is x minus 3. What I have to keep in mind is that there's an understood set of parentheses around this bottom x minus 3, so I can reduce x minus 3 divided by x minus 3 is 1 times x. We don't usually write the 1. Here, x minus 3 for this first term is divided by x minus 3, so that just leaves me the 3 that's on top. Whenever you multiply a fraction by its denominator, the result is the numerator of the fraction. That's a basic principle to keep in mind throughout this. So x minus 3 times 9 is 9 times x minus 3, or I could have written the 9 on the other side. The order doesn't matter in multiplication. So now this is my new problem. No fractions, looks a lot easier. X equals 3 plus 9 times x. 9 times negative 3 gives you the minus 27. So this is the same saying plus a negative 27. Hopefully that's still not confusing to you with negative numbers, but it is. Just keep in mind subtraction is just adding a negative. So I could either write 9x minus 27 or 9x plus negative 27. So I have x equals 9x minus 24 when I combine the 3 and the negative 27. And I subtracted 9x from both sides to get numbers alone on one side and letters alone on the other. And that gave me a negative 8x on the left and a negative 24 on the right. I divide both sides by negative 8 and I get x equals 3. So x equals 3. Wait a minute. X can't be 3. If I put 3 in, I get division by 0. And if I try that, my 3 over 0, my calculator will tell me is an error even. So it turns out there is no solution to this equation because of the restriction. So the answer is, the solution set is called the empty set. This is the symbol for the empty set. So you always have to go back in rational equations and verify that the solution you get is allowable. It's not an exception, or it's not what we call an extraneous solution. The algebra of clearing the fractions will make us believe that this is a possible solution, but when we look at the original problem, we can't put a 3 into that equation, so that doesn't, and there's no other choices, so the answer is the empty set. So here's one for you to try. It's quite similar. Instead of a 1, though, you have a 3 under your last number, so your common denominator is going to have 2 factors. Stop the video and try this one, and come back and see the solution. Okay, you're back, so here we go. Our common denominator was 3 times x minus 2, remembering that these are grouped together by that fraction bar, so we can put parentheses around the x minus 2. So I'm multiplying 3 times x minus 2, but here I'm dividing by x minus 2. The x minus 2 and the x minus 2 will reduce, so I have 3 times x. That gives me the 3x. And the first term on the right, I multiply by 3 times x minus 2. Again, the x minus 2 is reduced, so I'm left with 3 times 2 is 6. And then 3 times x minus 2 times 2/3. This time the 3's reduce. If you multiply by a least common denominator, every fraction will be able to reduce such that its denominator becomes 1. In this case, it reduces because of the 3. So I just left with x minus 2 times 2. So 3x equals 6 minus x minus 2 times 2. I distribute the 2. The negative in front will have the effect of changing the sign. So the x was positive. When I multiply it by the 2 and take the parentheses away, its sign changes to negative 2x. I was subtracting 2, so that sign is going to change to addition because of this negative. 2 times 2 is 4, but because of this negative, it becomes addition. I could have written the 2 in the front and then distributed it if I saw that easier. So now with group-like terms, I get a 10, and I also added 2x to both sides. so that I get all the x's on one side. 5x is 10. I get x equals 2, but the problem is, if x is 2, I have division by 0. Again, I have no solution, or the solution is the empty set. Thank you for joining me in this intermediate algebra lesson, and you now have homework to work on, and there's some other problems in the guided notes. And please get help as soon as you know you need it by emailing, going to the tutoring center, or any other resource you have to get help. Thank you.